Yes.
Good evening. Yes, it is audible.
Yes, we will start soon. Welcome to Physics Cartoon Camera. Today we are going to discuss about class 9th standard work, energy and power. So the viewers, very good evening to everyone again. Yes, I'll start now soon. Almost everyone, all the students, teachers and audience, everyone reached. Yes, we'll start with Physics Cartoon Camera is providing science facts, recording classes from class 6 standard to MSc as per Indian curriculum, and hands-on experiments, laboratory experiments in physics, jobs in physics. You can see each and everything what about Physics Cartoon Camera. So who not subscribed, subscribe the channel, and daily 10 to 11 from Monday to Saturday. The live stream classes from class 9th standard to 12th standard with customized presentations, and the children's from the rural India, they can able to join. Hope it is very helpful to the students of the country. Now the chapter again, work, energy and power. the most important topic of class 9th standard CBSE. Before going to this chapter, what is work, energy and power, their measurements and units. So what is force? Force is nothing but push or pull on an object. Whether you push or pull, then we can call it as force. So what is force and how it is related to work? You can see here in this picture a box which is dragging by a boy. He applying F force. He applying F force, and due to that F force, the distance D moved. Okay? The distance D moved. Now, work, which means the product of force into displacement, there is an angle theta over here. W is equal to FD cos theta. What is work exactly? Work is done when the force is applied to an object, moves that object. You can see in the first picture, a person is dragging a box, and yes, the box also moving. So hence, this person is doing the work. This girl is keep on pushing the wall. Is it wall moving? No. So, he is not doing anything work. According to physics, you are not doing work if you are just holding the weight above your head. And you are doing work only when you are lifting the weight above the head. In physics, work requires both force and motion in the direction of force. Okay? I guess my camera is off. Just a minute. Yes, I guess I'm visible now. Yeah. According to physics definition, we are not doing work if you are just holding the weight above the head. We are doing work only when we are lifting the weight above your head. So work requires both force and motion in the direction of force. So the amount of work done by the force is equal to the force and the displacement at the point of application of force. So as you know that W is equal to force into displacement. So W is equal to force into displacement. We can alternate the formula. Force is equal to work by displacement. Displacement is equal to work by force. So when is work done 0? This boy is trying to push a wall. Is the wall can move? Exactly no. Yes, but he is doing work. Output is not there. Hence he is not doing work. Second case, you hold a box, quite perpendicularly you lift it top direction and you are moving forward direction. What happens? Both are again perpendicular. Force and the moment of a box all are in perpendicular direction. In this case also work done will be 0. So W is equal to FD cos theta. Now you can see if theta is equal to 0, which means an object freely falls down. Once object freely falls down, what happens? The force also downward direction. The movement of an object also downward direction. In this case, theta will be 0. Cos 0 is equal to 1. So as per the definition, W is equal to the product of force into displacement. So Fs cos 0 is equal to 1, which is Fs. Okay, so work done is positive. Example, a body fall freely under gravity. What happens? Obviously, which is positive. Once theta is equal to 90 degrees, cos 90 how much? 0. When theta is possible? Force and the moment, both if it is perpendicular, which means 90 degrees. So cos 90 will be 0, work done will be 0. A person lifting a bucket and walking in the horizontal direction is not doing work. If the displacement is in the opposite direction of force, theta is equal to 180, which means very simple experiment. Take a brick, put it on a surface, and we apply the force. Once we apply the force, brick can move along to the direction of force, but the friction will come in opposite direction to the force. Yes, both are opposite direction. So theta is equal to 180 degrees, which means a straight line. Cos 180 is equal to minus 1. W is equal to minus F cross S. So work done is negative. Work done by the frictional force is negative. Units of works are joules. So work done is equal to force into displacement. 1 joule is equal to 1 Newton into 1 meter. Because force units newtons, displacement units meter, work done units joules. 1 joule is defined as the work experienced by the force of 1 Newton through a distance of 1 meter. Bigger units of work, kilojoules, megajoules and gigajoules. 1 kilojoule, 10 cube joules. Kilo means 1000, 10 cube. Megajoules, 10 power 6 joules. 1 gigajoule, 10 power 9 joules. Okay. Giga means 10 power 9. Now there is a scientific conception of work. We have discussed in the above paragraphs a number of activities which we normally consider to be work day-to-day life. For each of these activities, we can ask some questions. What is work being done on? What is happening to the object? Who is doing work? These three questions, every activity once we can apply, then we will get the real scenario. There is a case study over here. Kamali is preparing for examinations. She spends a lot of time in studies. She reads books, draws diagrams, organizes her thoughts, collects question papers, attends classes, discusses problems with her friends, and performs experiments. She expended a lot of energy on these activities. In common parlance, she is working hard. Now, in this scenario, what is the work being done on? The work is being done on the thought process required to understand the text. What's happening to the object? The thoughts are getting generated. Who is doing work? Kamali is not moving. Kamali is still there. But the Kamali's brain is processing the thoughts to make her study. Hence, her brain is doing the work. Okay? Now, second case. Rahul is working hard to push a huge rock. Let's say the rock does not move despite all the efforts. Rahul gets completely exhausted. What is work being done on? On the rock. What's happening to the object? The rock does not move. Who is doing work? Rahul is doing work, not a stone. Now, when is work done positive and negative? There are two kinds of works. One is positive work, other one is negative work. So, when it is. Think of some situations from your daily life where we are doing work. List out of them. Discuss with your friends whether work is being done in each situation. Try to reason out your response. If work is done, which is the force acting on the object? What is the object on which work is done? What happens to the object on which work is done? You can see, we can think of any number of situations. I shall take two of them. Let's say, pushing a book to a height. Push a pebble laying on the surface. According to definition, when we lift a book or push a pebble, we do apply some force on it and they move. Hence, the work is being done. Also, the pushing force is responsible for the work done. Okay? Let a constant force F act on an object while displacement being S, let W be work done. We define work to be equal to the product of force and displacement. Work done is equal to force into displacement. Think of situations when the object is not displaced in spite of a force acting on it. Also, think of situations when an object gets displaced in the absence of force acting on it. List all the situations that you can think of for each. Discuss with your friends whether work is done in these situations. Now, object is not displaced in spite of force acting on it, pushing a heavy block which does not move. Force is being applied but the displacement is zero, hence no work is done. Ball rolling on a frictionless surface. In this case, we see the displacement, but since no force is applied, hence no work is done. So you can see both the cases. Ball is rolling on a frictionless surface. We can see the displacement, but no force is applied on it. But displacement is there, hence no work done. Now there is a question for all you audience. A force of 5 newtons acting on an object, the object is displaced through 2 meters in the direction of force. If the force acts on the object all through the displacement, then work done is. Yes, anyone, the students who are in the live, you can answer this question. Apply the formula W is equal to F into S. Force value 5 newtons, displacement 2 meters. So what is the work done? The work done, W is equal to F into S. Force will be 5 newtons. S will be 2, which is 10 joules. Clear? This is the work done. Yes. Or 10 Newton meter. Anything also fine. Next. Parvati stands still for a few minutes with a heavy load on her head. She gets tired. She has exerted herself and has spent quite a bit of her energy. What is the work being done on? On the load. What is happening to the object? Load does not move. Who is doing work? Parvati is doing the work. Now, there is a question. A force of 7 newtons acts on an object. The displacement is, let's say, 8 meters in the direction of force. Let's take it the force acts on the object through the displacement. What is the work done in this case? Anyone can answer this question? The audience? Generally, students will feel numericals are difficulty. We are unable to solve the numericals. Each and every class I am suggesting that read the question, write given data and required data. So given data over here, the force of 7 newtons. So the given force. force is equal to 7 newtons. The displacement, let's say S is equal to 8 meters in the direction of force. Now, what is the work done? W is equal to F into S, which is 7 into 8, 56 joules. Clear? (56 joules). So what's the work done by the gravity? It is the work done on the body by the gravitational force exerted by the earth. Work done is equal to force into displacement. So force of gravity on a body is equal to weight on the body. Yes. Once an object which is lifted height h, what happens? There is something like a potential energy which is holding a mass of m. A mass of m we lifted height h. Okay. So now the force F is equal to ma. Against gravity we are applying the force. Acceleration due to gravity m into g, that is force. You applied some force and lifted height h. So what happens? W is equal to F into S. F value how much? mg into height h. So W is equal to mgh. Clear? Next. There is a question for you based on this. A porter lifts a luggage of 15 kg from the ground and puts it on his head 1.5 meters above the ground. Calculate the work done by him on the luggage. Yes, anyone can say this answer? We will see. What is given data? What is given data? We always write given data because it will save some time in examination time. We no need to read the question number of times. Given data, the porter lifts a luggage of 50 kg, which means let's say mass 15 kilograms, and puts on his head of the above 1.5 meters, which means distance 1.5 meters. Calculate work done. Calculate work done is required data. It is required data. So W is equal to how much? Just now we have studied formula. W is equal to force into displacement. Okay, force into displacement. Force how much? F is equal to m into a. A means gravitational force, g into s. So mass value 15, g value 10 into distance 1.5. 1.5 into 10, 15. 15 into 15, 225 is the right answer. 225 joules. Clear? Next. Yes, so this is the way. 225. Is work scalar or a vector quantity? Work is a scalar or vector quantity? Just now we have discussed work can be changed at any one of the direction. So it is scalar quantity. Alright. Next. An object moves in a circular path at a constant speed. The amount of work done by the centripetal force is negative, positive, 0. Negative, positive, 0. Answer 0. Yes. A crane pulls up a car of mass 500 kg to a vertical height of 4 meters. Calculate work done by the crane. Repeating again, a crane pulls up a car of mass 500 kilograms and vertical height of 4 meters. Calculate work done by the crane. So mass M is equal to 500 kilograms. Vertical height S is equal to 4 meters. So W is equal to work done they're asking, that is required data. W is equal to mgh, which is 500 kilograms into 10 into 4, that is equal to, or else here you place a 9.8. Other than 10, you can consider 9.8 exact value, because here 19600 also is there. In this consideration, use 9.8. That is equal to 2000 into 9.8, which is 19600 joules. So this is the right answer. Okay. Now, when do we say that work is done? Write an expression for the work done when a force acting on an object, if the direction of its displacement. Define 1 joule of work. A pair of bullocks exerts a force of 140 newtons on a plough. The field being ploughed in is 15 meters long. How much work is done in ploughing the length of the field? These questions are the answer. You can send email to me. Now you can see this kind of pictures we are seeing in TV. What is energy? Who is having here more energy? Is the tire having more energy? Or the hammer having more energy? This gentleman having the more energy. So what is energy? Energy as simple. The students, if we ask, they will say number of answers. As simple we can able to explain. Let's say how to explain energy in classroom. If I ask a student, what is your energy? He may say a number of words. Yes sir, I have energy. Yes, more energy, or little energy, or something else. But what is energy? How to define energy? Then we can ask a question to the student. I gave you 1 kilogram, 5 kilogram, 10 kilogram, 50, 70, 80, 90, 100 kilograms we have given. So what is the maximum weight you can able to lift? Let's say one person told, yes sir, I can able to lift up to 70 kilograms. Now we can ask, 71 can you able to lift? Probably sir. 1 kilogram only na, 70 I am lifting, 71 also I can be. 72? Might be sir, yeah, maybe little weight I can. 75? No sir. So he will say that up to 75 maximum I can able to lift, which means that is his energy. So the energy we can define as the capacity to do the work or the capability to do the work called as energy. Hope it's clear. Next, when a fast moving cricket ball hits a stationary wicket, the wicket is thrown away. An object when raised to certain height gets capability to do the work. When a raised hammer falls on the nail placed on the piece of wood, it drives the nail into the wood. Now, energy, as we know that, kinetic energy and potential energy. Kinetic energy, which means energy of movement. Potential energy, stored energy. Under kinetic energy, thermal energy, mechanical energy, electrical energy, magnetic energy. So thermal energy, which means energy of moving particle. Mechanical energy, energy of objects in motion. Electrical energy, energy of particles moving through a wire. Magnetic energy, energy causing push or pull. So now, chemical potential energy. Chemical energy, energy stored in food, fuel. Elastic energy, energy stored in objects that are stretched. Nuclear energy, energy stored in center of particles. Gravitational energy, energy stored in object when it is above the Earth's surface. So coming to, we experience energy in a different ways, like a sound energy we can hear from here, and light energy our eyes can able to detect it. Now, thermal energy, mechanical energy, magnetic energy, electrical, chemical, nuclear we are seeing. So what is finally kinetic energy? The energy possessed by a virtue of the motion. Let's say fast moving ball, capacity to fall down the pins. Thus it's having kinetic energy. Bullet fired from a gun possesses a very high velocity and hence kinetic energy. Apple fall from height, again that is kinetic energy. Now how to prove that K is equal to half mv square? Here I can derive in another way. Ke is equal to half mv square, we need to derive it. Let's say a mass m, we applied F force. What happens? Mass m, it moves. Yes, it moves up to certain distance. Yes. Now there is a work done. Work done is equal to force into displacement. So as per the Newton's second law, force is equal to mass into acceleration into displacement, we can write it. As per Newton's third equation, v square minus u square is equal to 2as. From that, a is equal to v square minus u square by 2s. That you mention over here. So m into v square minus u square by 2s into s. S will be cancelled. So w is equal to m into v square minus u square by 2. Initial, when an object at a starting, initial velocity u is equal to 0. So w is equal to half mv square. This work done in the form of kinetic energy, which means mobile energy. That is the reason the ball is moving. Ke is equal to half mv square. So this is the way also we can able to prove it. Next. Yeah. Kinetic energy we can call it as a work energy theorem too. Both are same. Now let's say a question here. An object of mass 15 kilograms is moving with a uniform velocity of 4 meters per second. What is the kinetic energy possessed by object? Option A, 490 joules. Option B, 200 joules. Option C, again 200 joules. Option D, 120 joules. Here the two options are quite similar. We will see what happens here. Kinetic energy Ke is equal to, there is a given data. Mass m is equal to 15 kilograms. Okay. Uniform velocity v is equal to 4 meters per second. Alright. So now required data K is equal to half mv square, which is half into 15 into 16. So 2 8 now 120 joules is the right answer. So what's the right answer? Option D is the right answer. Clear? Yes. Any doubt over here? So The energy of a body is its capacity to do the work. That is, the body of capable of doing work is said to be possess energy. The energy possessed by a body is measured by the amount of work that can perform. The unit of energy is the same as that of work. As the unit of energy is joules. Alright? Fine. So this is the way 120 joules. We got it. Yes, audience and students. Hope you understood that how that kinetic energy, how that potential energy, these concepts, and kinetic energy derivation. Let's say one more question. What is the work to be done to increase the velocity of a car from 30 km per hour to 60 km per hour if the mass of a car is 1500 kilograms? What is the work to be done in the increasing of the velocity? So initial velocity u is equal to 30 kilometers per hour. Final velocity v is equal to 60 kilometers per hour once the mass of a car is equal to 1500 kilograms. So what is work done? W is equal to again K is equal to half mv square. Here before half mv square we derived that half m into v square minus u square. Here initial velocity existed. So once we apply all the values here, mass value 1500 into v square, which means 60 whole square minus 30 whole square. Okay. So once if you do that, probably we will get the answer of 156250 joules. Next. So this is the way. And here 30 km per hour we have to convert into meters per second. Again 60 km per hour we have to convert into again meters per second. 16.67. That we need to substitute v square minus u square. What is kinetic energy of an object? Write an expression for the kinetic energy of an object. What is the kinetic energy of an object of mass m moving with the velocity of 5 meters per second square is 25 joules. What will be its kinetic energy when its velocity is doubled? What will be its kinetic energy when velocity is increased 3 times? So these are all the questions we can able to answer. Hopefully you understood that what is kinetic energy, what is work, and what is energy, and the kinetic energy definition, and there are few numericals beyond this. Coming to what is potential energy. The energy possessed by a body by virtue of its specific position, which is denoted by U. Now, forms of potential energy, one is gravitational potential energy and elastic potential energy. The potential energy possessed by a body due to its position relative to the center of Earth, it is negative. Gravitational potential energy is directly proportional to distance from Earth. Gravitational potential energy is 0 at infinity. Okay. And the potential energy possessed by a body in the deformed state due to its change of configuration, measured as the amount of work done in deforming the body. So, potential energy, which is stored energy, this energy which is in motion, kinetic energy. Alright. Now, P is equal to mgh. We can discuss how P is equal to mgh came over here. Let's say an object of mass m, we lifted with height h. Up to height h we lifted. So the distance is height h now. There is a work done. W is equal to force into displacement. So F into height h. So force is equal to mass into acceleration into height h. So m into g into h. So work done in the form of potential energy. Alright, we'll see. Yeah. Now, there is a question for you. Find the energy possessed by an object of mass 10 kg when it is at the height of 6 meters above the ground, when g is equal to 9.8 meters per second square. So find the energy possessed an object of mass m. An object of mass m is equal to 10 kilograms when it is the height h 6 meters and g is equal to 9.8 meters per second square. So W is equal to mgh, which means 10 into 9.8 into 6. So 10 into 9.8 exactly 98. 98 into 6. Probably 588. 588 joules we will get it. Okay. Yes. So this is the way the potential energy numericals in CBSE they'll ask. Next question. An object of mass 12 kilograms is at a certain height above the ground. If the potential energy of an object is 480 joules, find the height at which the object is with respect to the ground. So G is equal to 10 meters per second square. So we can see here mass m is equal to 12 kg. Certain height above the ground. Okay. If the potential energy PE is equal to 480 joules, find the height, and G value they have given 10 meters per second square. So PE is equal to mgh. H is equal to PE by mg is equal to 480 divided by 12 into 10. So 4 meters. Hope you understood that. Work energy. And the next continuation tomorrow will continue. Thank you so much for coming to live session and understanding the few concepts. In further upcoming lives, you will see very interesting presentations and explanation. Probably many changes you will observe in the next week. So this week successfully ends. And please review all the recording classes for all class 10th standard, 11th and 12th standard students. I'm posting recording classes. At the same time, the Rural India students, most number of emails are received to take the classes. Yes, I'm very humble to teach them, especially from rural India. Thank you so much. Have a nice day. Good night. Jai Hind.